Hey, this is Harry, and this is Physics 2 Lab 4, Circuits and Capacitors. Introduction. In this lab, I predicted and observed the behavior of circuits containing resistors in parallel and series. Use ammeters to measure the current in a circuit. Use voltmeters to measure the voltage and potential difference between different points, and survey the behavior of ohmic resistors and capacitors. This was done using computer simulations. Here are some important concepts, including like the energy conservation, the loop rule, current conservation, the charge conservation, and steady state, and ohmic resistors and capacitors. So in part 2.4, the voltmeter read 3V, while the ammeter read 0 amperes. The ammeter read 0 because when the voltmeter is placed in the circuit, because of its high resistance in comparison to the total potential difference, it makes the current close to 0. And this is like referencing the Ohm's law. In part 2.5 to 2.8, delta V's were around the circuit. So in 2.5, I measured the potential difference at different points on the circuit. And here it is right here. 2.6, the current was 0.02 amperes. And 2.7, the potential difference should be 0 for round trip. That's what I predicted. And my measured differences add up to 0. And this is like the graph of how it changes over time. Well, the different parts. Part 2.12, calculating the resistance. These are my calculations for the resistance of the different parts of the circuit. Part 3, charge and discharge times for the capacitor. And in this part, I recorded the time it took to charge the capacitor and discharge the capacitor with a 10 ohm bulb and a 20 ohm bulb. Part 3.1, ln delta V over ln over delta V naught versus time plot and RC calculation. So I recorded the information for this using the potential difference I got over like 20 seconds, and I plotted it. And then from there, I used a slope to calculate the value of RC. RC is equal to -1/2 of the slope. Well, negative 1 over the slope. I got 5.67 for my like experimental values, and the actual RC was 6. So they're close enough. And I'd say that my computed value like agrees with the value in my computation discussion. So for the first question, a real ammeter might produce some resistance and would add on to the total resistance of the circuit. For the second one, in an ideal situation, the capacitor would charge instantly, but realistically, since all the parts of the circuit have some resistance, it will take some time for the charge. Thanks for watching.